Hi everybody. This is another video to practice some factoring. So, because this never hurts to see a few more examples. Because the majority of students tend to like the T-chart method, all of these are going to be done using the T-chart technique. So, my first function is f of x equals negative 5x squared plus 8x plus 4. I don't like this negative out in front. We want to try to keep our leading term positive as much as possible. So I'm going to treat -1 as a GCF because it doesn't have any other common factors. So I'm just going to pull out a -1. That's going to leave us with 5x squared minus 8x minus 4, because all the signs will change since I'm taking out a -1. You are always able to pause here and redistribute the -1 to make sure that you have all the signs correct and you get the same function back. Then we ask ourselves if what we have left is a quadratic. And yes, it is. It does stick to the form ax squared plus bx plus c, which means we can identify our a, b, and c values. So here, a is 5, b is -8, and c is -4. Step number 2 is to multiply a times c. A is 5, c is -4, and when we multiply them together, we get -20. The question that we ask ourselves is what multiplies to give us -20, but adds to give us -8. And just as a reminder, I'll write that here. What multiplies to get -20, but adds to get -8. That's what we need to answer. So I'm looking for two numbers that multiply to give us -20, but add together to give us -8. The only combination that will do that is -10 and 2. You can list all the other factor combinations, and then you can just use process of elimination to find the one that works. Remember, if you can't find one, it is possible that it's not factorable, and then you would simply write that it's not factorable, okay? So this is our combination. So I set up my T-chart. The top two spots of the T-chart go ax squared. So in this case, it's 5x squared. In the bottom two spots of the T-chart go the two numbers that I came up with paired with x. So -10x and 2x. Then I look at each side of the T-chart separately, and I simplify each side as if it was a fraction. So if I simplify 5x squared over -10x, the top and bottom are both divisible by 5x, and that's going to leave us with x over -2. If I simplify 5x squared over 2x, only the x's will cancel out, and it leaves me with 5x over 2. And then I put everything back together. So my function, f of x, is -1, because that was the original GCF, times x minus 2 times 5x plus 2. At this point, I could stop and I could redistribute these factors to make sure that I get 5x squared minus 8x minus 4. And then I would verify that I do have the fully factored function. So this is my fully factored function. Okay, next example. Now I have the function f of x equals 8x squared plus 12x minus 36. First, I look for a GCF. I have 8x squared plus 12x minus 36. They're all divisible by 4. So I'm going to take out a 4 to start. When I divide everything by 4, I'm left with 2x squared plus 3x minus 9. Then I look for, well, I looked at this as a quadratic. So yes, this is a quadratic. I compare it to ax squared plus bx plus c so that I can identify my a, b, and c terms. And then I multiply a times c. So a here is 2, c here is negative 9, and so I get negative 18. The question is what multiplies to give us negative 18, but adds to give us positive 3. The combination that does that is 6 times negative 3. That will multiply to give us negative 18, but it'll add together to give us positive 3. Then I make my t-chart. The leading term, 2x squared, goes in the top 2 spots. The new numbers that I just came up with paired with x go in the bottom 2 spots. I simplify each side of the t-chart separately. When I simplify this, 2x squared over 6x, they're both divisible by 2x. So that's going to leave us with x over 3. When I simplify 2x squared over negative 3x, they're both divisible by x. So that's going to leave us with 2x over negative 3. And then I put the whole function back together. GCF was 4. And now my 2 parentheses are going to be x plus 3 and 2x minus 3. And again, if you wanted to pause here and redistribute, you can verify that you get the same polynomial back. All right, so these were a couple more examples using the t-chart. Now I'm going to show you what we call special cases that can occur. And one of them is a pet peeve of mine. So I want to make sure that everybody is aware of it. So let's take a look at f of x equals 9x squared minus 24x plus 16. I'm not going to know that anything is special about this. So I'm just going to go about this like normal. I look for a GCF, 9, 24, 16. 9 and 16 don't have anything in common, so there is no GCF. The GCF is 1. I can't do anything with that. So then I move on to the AC technique. If I multiply AC, the A is 9, the B is negative 24, and the C is 16. So I'm doing 9 times 16, which you can do in your calculator. And I get 144. Our question is, what multiplies to give us 144, but adds together to give us negative 24? And the answer is negative 12 times negative 12. Same exact number. So when I go to make my t-chart, I'm going to see something happen. The leading term, 9x squared, goes in the top 2 spots. These 2 of the same factors go in the bottom 2 spots paired with x. And I can see that when I simplify, I'm going to get the same exact reduced fractions. This are divisible by 3x, and that's going to leave me with 3x over negative 4, which means this side is going to leave me with 3x over negative 4. And so my final factored form is going to be 3x minus 4 times 3x minus 4. same exact thing being multiplied together, which means if I combined them, I can write this as 3x minus 4 squared. And that's the same thing because you remember what the exponent of 2 means. It means that you multiply it with itself. So I would literally expand this to be 3x minus 4 times 3x minus 4. So the reason that this is a pet peeve of mine is because if students start with this, they think that they can bring the power of 2 in. That is not an exponent rule. If you remember, exponent rules do not work over pluses and minuses. This 2 is not allowed to come in. You have to expand it out and write it as 3x minus 4 times 3x minus 4. Okay? So this is a big no-no, okay? So I'm going to show this. If I wanted to multiply 3x minus 4 squared, I cannot say that it's 3x squared and minus 4 squared. That is not the same. This is bad, okay? We're not going to do that because exponent rules do not work over pluses and minuses. If you see this, the only way that you're going to get a happy face is if you literally expand it out and then do your multiple distribution. This would give you 9x squared minus 12x minus 12x plus 16. And when you combine minus 12 and minus 12, you get minus 24x. This is the right way to do it. That's how you're going to get your happy face. So please make sure that you don't fall into this very common mistake. You have to remember that your exponent rules only work for multiplication. So that's one special case. This is actually called perfect squares. Okay, and now let's look at our last special case. We're going to look at x squared, f of x equals x squared minus 25. You can see why this is a special case because there is no middle term. So the first thing I'm going to do is I'm going to force there to be a middle term. If there's no middle term visible, that means there must be a 0 there. So I'm going to put in a 0x. And now I can go through the whole rest of these steps. I look for a GCF. There is none. I multiply AC. In this case, A is 1 and C is negative 25. So I'm getting negative 25. And my question is, what multiplies to get negative 25 but adds to get 0? So it has to cancel out. What multiplies to give us negative 25 but cancels out? The only combination that does that is negative 5 times 5. So I go to make my t-chart. The x squared goes on top. Negative 5x and 5x go on the bottom. When I simplify these, the only thing they have in common is x's. So I wind up with x over negative 5, and I wind up with x over 5. And that tells me that my fully factored function is x minus 5 times x plus 5. The reason that this is a special case is because this is called a difference of squares. If you look from the very beginning, this is a perfect square. 25 is a perfect square. This is a difference of squares. So we can actually label this. This is called a difference of squares. And if you notice this to be the case, you can go straight down here and just do a plus and a minus, okay? And you would put in their square roots. But I wanted to show you the whole process because the process is not too time consuming to do. You don't have to memorize any of these special cases. You can easily still get down to the answer still by doing the normal T-chart technique. Just remember that you have to make sure you still have that B term. So I hope this made sense. Please remember not to fall into that trap of misusing your exponent rules, and have a wonderful day.